Hello everyone, and in this video I'm going to be showing you how to make this moving obstacle using this script right here that I will show you how to actually write out. And we can make any sort of movement, so I'll show you along this direction here, and it will use that movement and it will go along that direction. We can also add a rotation in, so if we do 50 here, and you can do this little rotation here. And you can also have an endpoint wait time, so if we do 3 seconds, and it'll kind of stay there and just rotate. We can also make it full cycle and half cycle, so what that means is if we go like this, you can see that it changes between just here and here, rather than doing the full cycle between these 2 points. So I'll show you that that works as well. And so you just go in between these 2 points. You can also make the completion time smaller and make it move faster. And so yeah, that's what this video is about, so let's get into it. So let's get started in here. I have a brand new scene with nothing really in it except for some ground object and a cube that we're going to be using to test on. And so we'll just create a new moving obstacle script, and this script is going to be all that we need in order for this to work. So I'm going to go ahead and open it up. And we'll just delete out all these methods in here. And we'll start with a vector3 movement. So this is going to be how we're going to tell this object to move. And then we're going to have another one for rotation. So this is going to be how we want our object to rotate. We're also going to need to have a float that is the completion time. And so I'll give it some value of 3. And then if you want to have a endpoint, like stall time, you're just going to say endpoint stall time, and I'll set mine to 2. Now we're going to need to have a float t, and this is going to be what allows us to linearly interpolate our movement. And then we're also going to do a float dwell timer, and this is just for the ending points. So we're going to say 0f, and for this one we're also going to say 0f. So now then, let's get our start. And then we also need to have a vector3 starting point and vector3 target point. And now in order to make this a bit more useful, we're also going to have a bool that's going to tell us if it's going to be a full cycle. I'll set mine to true by default because I like full cycles. And so we're going to say that the target point is going to be equal to our transform.position plus movement. So what this does is it moves our point, our position, to the final position, and that's our target point for the very first iteration. And then this is where we're going to have to ask if it's a full cycle. If it's a full cycle, we're going to say that the starting point is equal to transform.position minus the movement. And actually what we could do is we could just say transform.position is equal to transform.position minus the movement. And then we can just say for here that is transform.position. If it's not the full cycle, so if this is not true, then we're just going to say that the starting point is equal to transform.position. And actually, since we use this in both cases, we could actually just go like this. So if the full cycle, then we're going to move it to the actual starting position, and then we're just going to set it here. Now then, the only other thing we need in here is an update method. And now in our update method, we're going to start with an if statement that sees what our remaining distance is. And before I forget, we're also going to need a end point distance threshold. Now you could actually make this just not serializable. It doesn't really need to be edited in the editor here. However, just for video's sake, we're going to do it like that, and we'll say transform.position, and then we'll say target point. Now what this is going to do is it's going to see how far away we are, and just because in Unity all float points are not always perfectly exact, this endpoint threshold is going to be just a little bit higher than 0. And that's just going to make sure that we're at least close enough that we're kind of at the endpoint. So if we're close enough to 0, then we're going to go ahead and do something else. Also, this needs to be distance. We're going to do, so at this point we're going to start incrementing our dwell timer, and then we're going to check if our dwell timer is greater than or equal to the endpoint stall time. And if this is true, we're going to want to store a temporary value at the target point. And then we're going to want to say target point is equal to starting point, and then starting point is equal to temp. So since we're overwriting our target point, we want to save a temp, and then we're going to just reassign that. And so that's going to flip it between the starting and ending points. And then at this point, we can also say that our t is equal to 0, and that our dwell timer is equal to 0. So this resets our t value and resets our dwell timer. And we'll come back to what the t value actually does right now. So we're going to increment our t value by time.delta time divided by the completion time. So if you know what linearly interpolating is, it needs some sort of t value, and I'll just start showing it here. So vector3.lerp, and it needs this float t. Now what this float t is you could kind of think of it as a percentage between point A and point B. So if the float is 0.5, then we're halfway between A and B. So we're 50% between the two. We're right in the middle. If we're at 0.75, so 3/4 of the way there, then we're 3/4 between A and B. We're closer to B than we are to A. And on the other hand, if we're 0.25, then we're closer to A than we are to B, and we're like 25% the way to our target position. So that's what this t value is, and the reason we're taking time.delta time divided by the completion time is, if you think of it this way, let's say our completion time is 3. And let's just say, now this is not realistic, but if the time.delta time is really high, say 1 second. So if every frame is coming in and it takes 1 second for that frame to get there, then we're going to say 1/3 is, we're going to say t plus equal to 1/3. And so now we're 1/3 of the way there. And then the next frame, if it also takes 1 second, we're going to say 1/3 plus 1/3, and now we're 2/3 of the way there. And once again, if it's another 1/3 comes in, then it's 3/3, which is 1%. So we're 100%, which is fully there. And so that's how we're doing this. Is we're going to take every time that the time it takes to get the next frame divided by the entire completion time. And so this is giving us like the time it takes to get there between each frame. So we're going to say from the starting point to the ending point, actually target point, and then we're going to say t. And then we're going to say that our transform dot position is equal to this. So we're setting our position equal to this linear interpolation. Now the reason I'm doing it like this is that we don't want our object to speed up and slow down as it gets to those edges. So the reason I'm doing a start point and an end point rather than doing something like this is another option you could do. So this is another option you could do. And right here you could multiply by some sort of speed value. So this is another option you could do. But the reason I do not do it like this is because this is supposed to be some sort of moving obstacle. And I'm going based off the assumption that it is going to be the same speed throughout the entire duration that is going in between its 2 points. So this one, on the other hand, as we get closer to our target point, the distance between these two things are smaller, so it won't matter what this is, you'll start to slow down. So you can kind of see it will go like this. This is how ours will go, is nice and the same speed, but if it was the other one, if it was this right here, what would happen is it would go like that, where it kind of speeds up and slows down. So we're not going to be doing it that way. And so the last thing that we need to do, which is actually really easy, is just handle the rotation. And so all we need to do for that is we need to say transform dot rotate, and then we need to say our rotation times time dot till time, and just to make this frame rate independent. So this should be everything that we need. This should work. One other thing we want to maybe do for visualization is say on draw gizmos, and we say gizmos.color. Now this is definitely not needed. This gizmos part is not needed. It's just for making it easier to see. So we're going to say draw line. Actually, we're going to also say if full cycle. And then we're going to draw a line between the transform.position minus movement, and then transform.position plus movement. And this one, since it will be a half cycle, then we only need to do that. So this should all work. And now we can do a little testing. So I'm going to go ahead and just kind of pull this up. You can kind of see this. This is the gizmos part. That red line is just the gizmos part. So this is the drawing. And if we kind of see how that affects it, and then we can just play the game. And you can see it's now moving. The smaller you make this completion time, the quicker it will take. So this is, I guess you could think of it as 3 seconds to get between these 2 points. So if we just change that to 1 second, it moves faster. This endpoint stall time is how long it's going to wait at each point. So if we just make this 0, it just won't stop. And likewise, if you make it negative, it just won't stop. So last thing we can kind of test is this. And you can kind of see it rotating now. And you can just do these on all axes. So now it's just kind of doing this nice little spinning here. And yeah, that's basically the whole thing. If you make a endpoint time, you can kind of see that it's still rotating. And so if we want to, what we could also do is just return out of this. And actually, you should do this return out of this anyways. So we're going to return out of this function if we're at our point. And then what this will do is that now when we get to the endpoints, so it will stop it. It will stop the rotation entirely, as you can see there. Now if you want the rotation to still be there and you don't want that to happen at all, what you can just do is just move this to the very top. So now it'll rotate first before it does this little check. And just, so now you can see it rotates even when it gets to the endpoint. So yeah, that's all it needs. You can actually apply this script to any sort of object. So if I apply this to the ground here, and then I give it its own movement, so we'll say like 50. And then, yeah, so the ground is now moving. So that's all there is to it. So thank you guys for watching. If you like this video, like and subscribe for more, and see you guys later.